In this lecture, we'll try to understand how two machines in a network can communicate with each other. Assume that I have machine A and machine B. How can they talk to each other? Definitely, to communicate over a network, we should be having a network interface. So, on machine A, there will be a network interface, or we call it as an Ethernet port. Normally, by default, we use ETH0, first Ethernet port, the ETH0. This can be one network interface on machine A, and there can be ETH0, another network interface on this particular machine. Now, to connect these two machines so that they can communicate with each other, or there could be multiple machines like another machine C. Again, this also will be having its own network interface ETH0. Now, how to form a network using all these three machines? So what we can do is we can use a device called as a switch. So in switch we have multiple ports like this. What we can do, we can connect these Ethernet ports or the interfaces to the ports on the switch. So now the switch actually can be configured to form a network. Assume that I have configured my switch to use a network like 192.168.1.0. So this can machine A can be assigned like this interface basically, not machine. This ETH0 can be assigned an IP 192.168.1 dot something like 10. Here this I can assign 192.168.1.11, and for this I could assign 192.168.1.12. Now, once all these machines are connected to each other using a switch is a separate device which can actually know how to route the packets coming through these interfaces. Okay, so now if you ping from this machine A, if you ping this IP address, it'll actually ping it. So that's how by using a switch we can connect multiple devices on a network. Now, let's assume that I have two networks. So I have a network, I have another network. So in this network, there are multiple devices. Um, Assume that the network ID is 192.168.1.0/24 the network ID, and this network ID, let's say it is 192.168.2.0/24. There are two networks, and in these networks there can be multiple devices connected to the switch. Whenever I say network, assume that there is a switch using which all the machines are connected. I have these two separate individual networks. How to connect these two networks? Let's assume that this is machine A, machine B, machine C, and machine D. How can a machine on network, first network, communicate with a machine on second network? So for that purposes, we need a device called as a router. So what we can do is, again, on the switch we have multiple ports, right? One of the port will connect to router here, and for this switch also there will be another port will connect one port to this router. So for this router there can be multiple IP addresses, so we can assign an IP address 192.168.1.1 to this router here, to this interface. And here also the IP address for this port is 192.168 dot belonging to this network means 2.1. So that router can have multiple ports. We connected these two ports. Now, how can actually a machine be in this network know that it has to go through this router for reaching C? What we can do is we can add a route on this particular machine B. Suppose if I want machine B to be able to reach C, it has to go through this 1.1, right, on the router. So on machine B, what I can do is I can execute a command like IP route. I had to add an entry to something called as a routing table. IP route add what? 192.168.2.0/24. So for any IP falling within this network, it has to go through what? Via 192.168.1.1. This is the IP. So I'm saying from B, if it has to reach any IP belonging to this network range, it has to go via this one. Similarly, on machine A also, I need to add this routing table entry. Now coming to C, machine C, how can C reach A or B? Even in either C or D, we have to add one more routing entry. How? IP route add for any IP in this particular range 192.168.1.0/24. It has to go via what? 192.168.2.1. So if C has to go to B, from C it has to ping A or B. I am saying A or B falling to this network, right? I am saying it has to go via this one. So suppose um, again this router is connected to one more network identified by 192.168.3.0. This is another network. Like that, router can connect to multiple networks, right? So I want to say that from either C or D, whenever the IP range does not fall within this particular network, I can say default is, instead of adding this one, I can use default. That means from C or D or any machine on this network, from C, let's say, if we are trying to ping any IP which is not within this current network ID, the default route is 192.168.2.1. So it has to go through this port only. So once we add routing entries, then we will be able to reach. So these routing entries have to be added on machine A, machine B, machine C, machine D, etc. So like that, we can add a default route. These routes also are called as gateways. So within this network, what is the default gateway within this network? Suppose if I'm trying to ping any IP address outside of this network, the gateway is what? 192.168.2.1. This also belongs to this particular network only, right? 2.1. So this 2.1 is a default gateway I configured. And maybe for this network, I can configure the default gateway as this one. So we have to add the gateways. Okay, once we are done, we'll be able to uh, ping from one network to another. Okay, so we understood about the basics of how one machine in a network can ping other machine in another network using a router. Okay. One more thing I would like to talk about is a DNS entry. domain naming service or domain naming server. Normally, from machine A, if I have to ping machine C or any other machine, I need to actually remember the IP addresses. So remembering IP addresses is really difficult. Let's assume that on this machine C there is MySQL database. So to connect to MySQL database, I need to remember the IP. It will be very bad. So what I want to do is I want to give a name to this machine. So whenever I say ping MySQL, automatically this name has to be resolved to the IP of this machine. So we need name resolution. So what we can do is on this particular machine, on this on any particular machine, what we can do, we can maintain slash etc slash hosts file, and in that hosts file we can write a mapping like 192.168.2.2. The name is MySQL, or maybe for this machine, let's say it is Mongo. So 192.168.1.2 is Mongo. So like that, in this machine, if I give a name, if I'm mapping a name to an IP. So whenever I'm pinging or whenever I want to connect, I can use this name. That name will be resolved to the IP from a file locally called as etc slash hosts. But the problem is in machine A also, I have to map the IPs, entire IPs in my network to different names in etc slash hosts. It will become tedious, right? So normally what we do is we'll be having one server called as a DNS server, where in this DNS server under slash etc slash hosts file, we'll map the IPs 192.168.1.2 MySQL, 1.2.1 Mongo. Like that, the mapping of the IP addresses to names we maintain in a DNS server. And in all other machines within our network, what we do is we configure a file called as slash etc slash resolve.conf. In that, we give an entry um, for name server, um, whatever. Let's say the IP of this is uh, 10.109.168.1.100, whatever is IP of this DNS server, which should be reachable from this. I'll give here 109.168.1.100, whatever the IP of this DNS server. So from this, in all the machines, we just have to mention this entry and tell where is the name server located. So from any of these machines, whenever we try to ping an IP, the lookup will happen onto the DNS server with the name, get the IP, and then use that IP to connect. So this is called as DNS resolution. So normally in our network, we'll be having one DNS server centrally where we map our IP addresses to domain names. So that's about IP addresses and domain names. In the next lecture, let us try to understand about namespaces, network namespaces, how we can actually use network namespaces to create actually network isolation. So how it works in a container world, let us try to understand in next lecture. See you next lecture.